Welcome to the Nutley Cisco Academy. This presentation is on IPv4 and its limitations.
So when IPv6 was created, IPv6 was created because IPv4 has a couple things wrong with it. One of them being that it has a limited number of unique public addresses that people can use. So what ends up happening is more devices come out that need IP addresses, they end up sharing the same one. So how we tried to solve that was we created the network address translation, NAT. This provided a way that multiple devices could share the same IPv4. But what ended up happening was this limited end-to-end connectivity between multiple devices because it hid the IP address of a internal host network. Now, because we added NAT, it also messed up the IPv4 and it made it more complex, which causes more latency and makes troubleshooting more difficult.
IPv6 is essentially a better and more improved version of IPv4. Improvements that IPv6 has over IPv4 include increased address space. IPv6 addresses are based on a 128-bit hierarchical addressing as opposed to IPv4 with 32 bits. For a better idea of this, the 32-bit IPv4 address space provides approximately 4 billion unique addresses, while the IPv6 address space provides 340 uncillion addresses. Improved packet handling. The IPv6 header has been simplified with fewer fields. Eliminates the need for NAT with such large number of public IPv6 addresses. NAT between a private IPv4 address and public IPv4 is not needed.
Okay, you got it. One of the biggest improvements to IPv6 over IPv4 is the packet header fields. Basically, it really just simplifies what IPv4 has, because the IPv4 header only has 20 octets, while the IPv6 just makes it increases the amount and makes it a lot more simple. There are some changes to in IPv6 that were not in IPv4. But a lot of it really just remained the same.
So fields that are in the IPv6 packet header include version, which is a 4-bit binary value of 0110 that indicates that it's a IP version 6 packet, and traffic class, which is the same as the differentiated services field in IPv4. Flow label, which suggests that packets with the same flow label receive the same handling by the routers. Payload length indicates the length of the data portion or payload. Next header indicates the type of data payload. Hop limit is a value that goes down by 1 for every router that forwards the packet. And when it reaches 0, the packet is discarded. So it indicates that the packet didn't reach the destination if it exceeds the hop limit. And then the source IPv6 address indicates the address of the serving host, and then, or sending host. And then for destination IPv6 address, it's the address of the receiving host. And it can also contain extension headers, which are optional and are used for fragmentation, security, and supporting mobility and some other things.
Questions? Can you list at least 2 to 3 things that make an IPv6 better than IPv4? How many unique addresses can IPv4 create? What is NAT? And name 3 fields in the IPv6 packet.
Thank you for listening to the Nutley Cisco Academy. Remember, like and subscribe.